As important as the preseason events are to our team, the landmark event of every build season is the kickoff. Thousands of robotic teams get together to witness the moment when this year's entirely new game is revealed for the first time. This year, we attended a regional kickoff event hosted by the Chicago Robotics Alliance. The game this year involves shooting a ring into a thin chute, a ring into a high-angled chute, and climbing onto a chain. Once the game was revealed, no time was wasted. We got right to work brainstorming.
The team worked tirelessly, coming up with many ideas, some good, some less than optimal. But at the end of the day, only a few select ideas will make it through the rigor of prototyping and testing to be built into our final robot. After kickoff, the team was already showing signs of a promising season, especially after one of our rookies won trivia against hundreds of members of other teams.
But now, back in the lab, it is time to prototype. This allows us to produce working versions of the ideas we've come up with and test how well they'll work in a game scenario. This is where ideas get built upon, modified, mangled, and combined to produce our final designs. Eventually, we settled on a few prototypes we thought were worth trying out.
Alright, hey guys, so these are our field elements, or what we've made of them so far. Right here we have this stage where robots will climb on this chain. We haven't put the trap up yet, but it's going up there so robots can feed notes into the trap during in-game. Over there, Zach is building this the speaker. That's the frame of the speaker. And behind it, we have the amp, which we've assembled.
This is our pneumatic system. Well, we use air and high pressure to raise these pistons. And we're using this in the game right at the end. You can see we have the chain that we have to get the robot to hang on. So the way that we decided to solve this issue is to use these pistons that will extend up to a certain length and hang on the chain.
Okay, so this is the intake. The intake feeds the note into the actual robot. What we have is, we got the motor here, which just spins this gear, which spins this gear, which spin these hex shafts here. They're just like rods, and this is basically spins a little conveyor belt system. If we don't have a good intake, then we don't have a reliable way of actually getting the note into the robot. So it's really important that this works consistently and reliably.
Okay, so this is the prototype for our shooter. Now this is gonna be what shoots out the foam notes. Because it's made out of foam, we decided it's gonna be made out of rubber. This is very tolerant. It's got a lot of squish to it. The idea is that by using this rubber, it's gonna have more tolerances. Hopefully, this will make it a lot more reliable. Hopefully is the key word here. It's already working pretty well for a prototype. It's a little shaky because it's wood, but there it goes.
So what I've been working on is vision. There's these April tags that the robot can use to know where it is. Depending on which ID it is, the robot is going to aim the shooter. I've been modifying my code so that we could test it on last year's robot. It can know where it is at any point in time in the field.
What did we do this week? Well, we got a robot to drive 10 feet, shall I say. And so far, we're probably at least 3/4 away of building the FRC kitbot. The kitbot is a bot given to FRC teams to prototype and pretty much baseline an idea and over time improve on. It only has a certain amount of functions, like it can only do maybe 2 of the actual 5 things that it needs to do. Programming side, we're trying to still explore. It's core B. We have newer people, like freshmen and sophomores more or less, and they're trying to get into the groove of things and figure out what's what.